Hello. Hi everyone. I'm Dr. P. Usharani, Professor, RMD Engineering College. I'm going to explain about EE 8702 Power System Operation and Control MCQ for Unit 1 with the topic Parallel Operation of Alternators considering speed group characteristics. The question given us two generators rated at 400 megawatt and 700 megawatt operated in parallel. The speed group characteristics of their governors are 3% and 4% respectively from no load to full load. Assuming that the governors are operating in 50 Hz at no load, how would a load of 1000 megawatt be shared between them? What will be the system frequency at this load? Assume linear governor operation. Determine the full load speed for each machine. This is Anna University 2018 November question paper. The answer is 4 options they are given. In the 4 options, option C, 48.4339 Hz is the correct value. So the solution for this problem is, first you have to draw speed group characteristics for the two alternators. I am considering y-axis as the rated capacity of the alternators. Okay, x-axis, y-axis as the frequency. So OA as the frequency for 50 Hz, CA as the value. Alternator 1 rated as for 400 megawatt. From A point you have to draw a line, okay, for a triangle AED. Similarly, for alternator 2, the capacity is rated 700 megawatt. So you draw a line, speed group characteristics with the 4%. Okay. So A, G, F you complete. In that, what they have given us 1000 megawatt is shared by both the alternators. So I have considered CBH as the total 1000 megawatt. I don't know how much is shared by alternator 1 and how much is the remaining shared by alternator 2 from the 1000 megawatt. So I'm just kept X megawatt is shared by alternator 1 and 1000 minus X is shared by alternator 2. So my aim is I have to find out first this height, that is this frequency. Okay, this is the question F. Then I have to find out this X, that is load shared by alternator 1 and 1000 minus X load shared by alternator 2. Okay. So first you are using the formula of speed regulation, which is no load speed minus full load speed divided by full load speed. In the question they have given no load speed as 50 Hz. So considering first alternator 1 of the capacity 400 megawatt, okay, you are writing the speed regulation as 3% for the alternator 1. So 3 into 100, so 0.03, which is equal to no load speed as 50 minus full load speed. Full load speed means here the frequency you are taken, that is OD. Okay, OD as the frequency for this alternator 1. So I just substituted OD divided by full load speed again. So OD you put. So 50 minus OD divided by OD is equal to 0.03. So you find out OD from this equation. Simplify that. If you are solving, you will be getting 48.543 Hz. Similar to this, you can find the frequency of OF for alternator 2. Okay. So the speed group characteristics, they have given us speed regulation 4%. So that is 0.04. So 0.04 is equal to no load speed 50 minus full load speed here as OF for alternator 2 divided by OF. So if you simplify that, your answer is OF as 48.0769 hertz. You know now what is the value of OD and OF. OA as 50 hertz. So next, what we are taken as, we are considering alternator 1. You have two right angle triangles, they are in similar manner. So we are considering ABC, then ADE. Okay. In that you can write in this equation, that is CB. This is CB divided by ED, CB divided by ED, which is equal to AB divided by AD. So what is the value of CB as X? X divided by 400 equal to AB. AB as OA as 50. Then till your OB as you have taken as F. So 50 minus F as the height of AB. Okay. So instead of AB, you can substitute 50 minus F divided by AD. How you are calculating AD here as again this total is 50. 50 minus OD. OD you have calculated just now as 48.543. So 50 minus OD you are putting. Okay. 50 minus OD. If you are simplifying this, you are having this equation. Okay. In terms of frequency, you have one equation of X. This you just keep as equation 1. Okay. X in terms of you have the equation X is equal to in terms of frequency. Similar to that, you can find another set of equation for alternator 2. That is, you are considering these two triangles are similar manner. That is ABH and AFG. That is, you can write the equation BH divided by FG, which is equal to AB divided by AF. Okay, similar to that, you are writing and you are substituting BH value as 1000 minus X divided by FG as 700. Then you need AB. AB as a total height OA minus OB. OB as F. So 50 minus F divided by AF here as 50 minus OF. OF you have calculated. That is a 48.07679. So that you substitute. So you'll be having, if you simplify this, you'll be having 1000 minus X is equal to this value. In terms of frequency, you have one set of equation. That is, you just keep that as equation 2. So substitute your X value, that is equation 1 and equation 2. If you are substituting X in terms of frequency, so if you simplify that equation, your final answer for frequency is 48.4339 hertz. So that is the height of OB as the 1000 megawatt load shared by the two alternators at frequency of 48.4339 hertz. This is the answer for the given question. They have given the option, 4 option, that option C as the correct value. The option C is the correct answer. Okay, for the same data, they may ask how much is the load shared by alternator 1 and alternator 2 means. Okay, this is only frequency they are given the option. If they are given again load shared by alternator 1, alternator 2 means how can you proceed means I know my frequency. Okay, I have my two equations. Equation 1 is X in terms of frequency. Then I can substitute my X value here. I can find my X. Then I can find 1000 minus X. That is, I am using equation 1, substituting F as 48.4339 and calculated my X as 429.952 megawatt. This is the load shared by alternator 1. Okay. Load shared by alternator 2 as equation 2. This is 1000 minus X. So X value you substitute, you will be getting 570.04 megawatt. So you can find the load shared by alternator 1 as well as alternator 2. This is the final answer. Previously, I have put for unit 1 totally 3 videos. One is load curve for question number 1 to question number 4. Next, load curve 2 video, that is question number 5 to question number 8. And third video is parallel operation considering speed group characteristics. In that, I have solved one problem. So kindly see all the videos. Thank you all.